All right, hello everyone. I'm Kevin Barry. I do Nova Launcher, and I'm here to talk to you about interprocess communication. So first I want to talk about launchers, specifically Nova Launcher. Lots of people think that launchers is more than it is, but they also think it's less than it is. So really it's an activity, but it responds to the home intent. So when you press the home button, you get the launcher. So it behaves like an activity, like all the activities you use in normal apps. The big difference is that it's running all the time, which has a big impact on like memory management's much more important for something that's always running. And it's interacting with the system, that it's displaying all the icons on your desktop, and it gets that from the system. It's displaying app widgets, it gets that from the system. So yeah, that's what the launcher is. And I think that gives launcher developers kind of a unique view of Android. And so I'm going to talk about the launcher view of interprocess communication. So here's a rough graph of what Nova's doing. So Nova has some helper apps. We have Tesla Unread over here and Nova Launcher Prime over there. So Nova Launcher itself is a free app, but to get all the goodies, you need to pay for it. So that's, you buy Nova Prime as a separate app, and then Nova can communicate with that, find out that it's Prime, and unlock those features. Tesla Unread, which requires Prime, it gathers unread counts from different apps. So that means it needs to be talking to these different apps, or it needs to be having those apps update it, or talk to the system to find what apps have unread counts. And then it feeds that back to Nova. And then the bulk of the interprocess communication is Nova talking to the system. So that's, and that's all of our apps are doing that. That like when we're displaying a window on the screen, that's IPC. When we're starting an activity, either our own or another, that's IPC. So there's a large amount of interprocess communication in every Android app. It's just normally we don't notice it, and that's great because it's working. When we do notice it is when it's not working. Questions? I'm not really done, but I think I'm going to present better if you guys ask me questions, so feel free to interrupt. Let me know what you want to know, and we can talk about that. But I have some more slides, too, to give an overview. So there's different types of IPC. So it's not like I worked on IPC before Android heavily. I'd use it as much as, any developer might happen to use it, but so I don't really know the other methods well. But you can do things like you can use a TCP server. I was talking to someone who's using an HTTP server on Android just to send JSON to another process. So that works. Unix sockets, which lets, if you used X Windows, that uses a Unix socket. It looks kind of like a file, but you can write stuff there. Another process can read it. You can just read and write actual files. On Android, sometimes we will, if you have multiple processes in the same app, you might use the shared preferences file, and that's potentially dangerous, but it can work. You can have some communication there. Or the Unix command kill, that sends a signal. So you can, when you get some signal, you can do something. Maybe you're reading another file, so you have kind of those two methods, or maybe you just have the signal and you act on it. But on Android, we have intents, so that's for broadcast activities and services, and we have binders. Assume you all have used intents, but let's talk about what's wrong with them. So third-party apps, if it's, if someone comes up to me, it's like, hey, it'd be cool if we had this API for Nova Launcher in my app. What if we do it this way? And it's almost always suggesting broadcasts. And this because broadcasts are really easy to implement. You have on receive, you take some action, and you have a send broadcast to trigger it. The problem is that it's almost always wrong. You can't tell who sent that broadcast unless you actually say, hey, this was sent by me, but anyone could lie, or any app could lie. And this isn't just protected from malicious apps. It's that sometimes a well-meaning app might just say, hey, if I tell Nova that I'm Facebook, and I can say, hey, I'm Facebook, can you put on a red count of 5 on my icon? And that's because this well-meaning app believes that Facebook has 5 unread counts. But then Facebook tells me, hey, by the way, I have 6 unread counts. Now, what should Nova do? It can't trust either of those sources, and the user gets confused because something's wrong. You can technically protect broadcasts with a permission, but if you declare your own permission, it's really unreliable if you're not a system app. So when there's in your manifest, you can declare permissions. If you're installed first, you own that permission. If someone else declares permission and they're installed first, they own it. And so prior to, I think it was Marshmallow, they would both install. So your app declares its permission. I install, I think I own it, but actually you own it. you said anyone can have this. I said only people that are signed, only apps signed with my signature can have it. But you installed first, so you win. Anyone can have this permission. And I could check this, but it's but even if I know it's broken, what do? I just break the API? That's not good. On Marshmallow, it's better and worse. It's more secure. If your app is already installed and you declare the permission, my app won't install. But for your users, that's awful. They try to install your app. The Play Store says like error -505, and they're mad at you. So don't use third-party app permissions, which means broadcasts have no security. And then I just said you don't know who's sending it. Sometimes you don't know who's listening. If you're sending the broadcast, you can target it, like just send it to this app. But if you're sending it, as a general API, you have no way of seeing who actually received it. So what are binders? So binders are, they were started, I don't know if they were actually used on BOS, but they were started at B-Ink for a future version of BOS. Then they moved to Palm, and then finally made their way to Android. And this has been Diane Hackborn's been working on it at all these places. So if you see her talking about binders or interprocess communication, she can seem a little angry or something, but she's basically always right. So trust Hackborn. The idea is it gives object-oriented interprocess communication. And so sometimes the binders in Android are used, it's just like a token, like, I declare a binder and I give it to you, and now we both have this object, and we know, like, if I go away, you can see that I'm gone, and you can trust that it's from me, and you can verify the identity. But you could also have methods there that can be called, or sometimes it's used like, I'm calling a method in you, and I'm going to send you a binder that you can call me back when you're done processing or something. So as I said, one process creates it, sends it to another, and the way we send it is write strong binder. And now the other process gets a binder proxy that implements the same binder interface. So write strong binder, notice the strong here. This means this is a strong reference to that binder. So it's easy to introduce memory leaks. If you send a binder, like an anonymous interclass binder, part of your activity because you want a callback, now that service is holding on to your activity. So keep that in mind when working with these. But what you can do with the binders, transact, which that's the heart of it. That's how you call methods on it. But you can also just check to see if it's still alive, or you can get a callback when the owning process is killed. And so there's also AIDL. So this is when when you have a bound service, you can communicate over an AIDL interface. So this is it's a cleaner language to write these kind of ugly methods, but you write code as if, okay, I have this interface as these methods, it takes these arguments, and then it creates the actual binder implementation where it's calling binder transact. You can send primitives easily. If you want to send any more complex object, then you need to parcel it, and so it's a form of flattening it. And you can parcel binders. So you can be sending, you can get a binder from someone and send it to someone else, which actually can be useful for sending callbacks that let's say service. Okay, Alice has some service and she can give you a callback. I have permission to talk to Alice, and so I can ask for this and she can call me back. But really, I don't care myself, and then Bob, he cares, but he doesn't have permission to talk to Alice. So he could talk to me and say, hey, can you ask Alice this, and when you're done, call me back here, and I can just tell Alice to call back Bob, and I no longer need to worry about it. There's also content providers. So I actually really like content providers, and I feel they're kind of underused. I don't like the default database implementation because it just feels like it's so much, it's so much overhead if you just want to use the database in your own process. And I don't use a content provider if you're just using one process. It's a pain. Don't bother. But if you're doing interprocess communication, they're really cool. So they're basically already implemented AIDL. Has a few simple methods: insert, query, update, delete, and there's bulk insert and a few other things. But yeah, it doesn't need to be a database. I have several kind of providers. One of them is as few lines of code as kind of provider can be, and it's I call it API provider, and I just use it for custom commands. And you can also provide file streams. So really often, and this has to change now and then, but really often apps, when they're communicating, they're sending files in the form of a /SD card path, or slightly better a file path. But really, this is it's kind of like what I was saying. Broadcasts is a bad method, that you don't know who's going to read the file. You have to give permission. Anyone that has read SD card access has to be able to read it. And likewise, the receiver has to have SD card access. So like Nova doesn't need to have SD card access necessarily, but I always have to like prompt users at weird times because I get something back from one of your apps and it's a SD card path. Okay, so I want to talk about when to use different methods. So back to intents. Start activity is really great when you can get away with it. So either if you just want to send something off, can you send something off and be done with it, or send something off and get a result? So like cropping a bitmap, sending an email, picking a contact, using it in your own app makes perfect sense. Using the third-party apps, the main challenge is that you don't necessarily know, like there's no way of verifying that they actually uphold their end of the deal. So like they might say, they support a crop bitmap intent, but actually once you call them, they just show like a generic image picker and they never return anything to you. There's not a way around that. That's just kind of the nature of the Android ecosystem. Start service, likewise for start intent, except it's for background tasks. In theory, you could use start activity to start a background task, and in your own app that could work. You could start an invisible activity that does whatever. It's weird. Don't do that unless you have a very weird use case. But with third-party apps, it'd be much more dangerous. That if you're trusting this is going to be an invisible activity and it's not, it's very disruptive to the user. But one cool use of start service in a second process in your own app is Leak Canary. So if you haven't used Leak Canary, it's really cool. It's from Square. It helps you monitor memory leaks in your app. And so what it does is it kind of attaches a watcher. It sees that this activity is still around when it likely shouldn't be. And then it opens a new process. That process kind of debugs your app, gets a memory dump, analyzes it, and then posts a notification saying, hey, I found this leak. And bind service. So start service if you just want to start something, but you're not going to get a result, or you're not going to be able to keep interacting with it. Bind service lets you actually interact with it, and that's when you have to use AIDL. Developers, including myself, are hesitant to use this just because it's a pain to deal with. That like you're creating this AIDL, then maybe Android Studio doesn't sync, so you need to force a build in order to see it. Then you finally get it. Then you're returning these objects and you're forgetting to unsubscribe and you're leaking memory. So it's a pain, but it's needed for certain things if you want to get callbacks in the middle or at the end. And then content providers, my favorite, when you want to add, update, or delete data. And then when to abuse. If you're going to abuse something, don't abuse broadcasts, abuse content providers. You don't need to deal with AIDL because it already has some methods. They're just simple methods, but there's nothing telling you that you can't, say inserts, turn on flashlight. Like, okay, that's not content that you're providing or receiving, but it's a command, it's abusing the API, but it's really simple. You can do it sometimes. And the cool thing about this versus broadcasts is that you can actually check the identity. Binder.getCallingUID gives you the user ID of the process, and you can use that to look up the package. So you can verify who it is if you just want to allow your own apps or your friends' apps, or just so you can, when you're debugging, you're seeing something's going wrong, and you can log what app it's coming from, so you can try to reproduce yourself. And you're in good company. If you want to abuse content providers, Google does it too. Franco was saying, hey, Kevin, can you help me? I want to hack Pokemon Go, and I need to turn off the GPS, but Google doesn't let me. So in the settings provider, if you try to just use it like you'd expect a settings provider to work and add GPS to the string it stores there or remove it, it doesn't do anything. And that's because they're not actually they're not treating it as normal content in a database. They treat it as a command where if you add plus GPS, it'll turn on the GPS. If you add minus GPS, it turns it off. This is hacky. It's bad. The reason they're doing it for thread safety, that if the string basically could say GPS, network, cellular, and they don't want the user turns off GPS and turns off cellular, and these happen in different paths. They don't want to accidentally turn one back on. So they make it into a command. So you can do this sometimes. It's not good, but it's better than broadcasts. I guess actually I talked about permissions. So third-party permissions don't work reliably. When using binders, you can use this binder clear calling identity. So like my Nova API content provider, semi API of use. So one thing that I do there is, and I don't know if anyone's actually using it now, but like sometimes app widgets get misconfigured. And so app widgets are kind of weird because it's the app widget, the user sees it as it's part of, I'm going to use HD widgets as an example because I was working with them on that API. So HD widgets, it's a clock, it shows some weather, and they see it as all belonging to HD widgets. But really what happens is HD widgets tells the system, here's what the widget looks like, and the system tells the launcher, here's how to display it. So what they wanted is they wanted a way to delete the widget, and they could replace it like Hangouts did, just hey, this no longer works, and that's a really bad experience. But they want to delete it from the launcher. And so I did something where I have HD widgets can connect to my content provider. I can check their binder identity. I see who they are, and then I see that there's a widget that they own, and they want to delete it. Like, okay, I can trust them to delete their own widget. I'm not going to let them delete a widget from another app, but for themselves. But so when doing that is that when I want to talk to my own database, my own content provider, I need to use binder clear calling identity. And that's because otherwise the binder kind of remembers that it originally came from HD widgets, even though it's in my API content provider. Now it's going to go to my actual database, and it still knows its identity, and that doesn't have permission to write to it. So binder clear calling identity lets you replace the caller with your own, and you can use that to kind of escalate permissions. But remember to restore it later, or else things can get weird. And so another cool thing with permissions is you can, sometimes you have activities and you don't want to export them for a reason. And so this is an important part of Android, is that you want to be able to launch your own activities or providers or services, and you don't trust another app to interact with it. And this might be an actual security issue, if it's bypassing your lock screen or something. But it's also, it's just a sanity thing that, like, if you're debugging, you don't want to see crash reports from someone, jumping into an activity that you shouldn't. And I'm guilty of this, that if you guys do export activities, Nova shows them to the users. So, like, users can go in Nova and add a shortcut. Nova has this activity shortcut where I show everything you export. And often these will crash, but users kind of understand that because they're reaching in. You guys get the crash reports, and that's, sorry, don't export them. Or check the intents when you get it, and if it's just, a generic blank intent that's from me or another launcher, and just, do something else, don't crash. But so if you don't export the activity, then you can use binders, you can use interprocess communication to allow another app to still access it. So like this is all like pending intents. They can access your own non-exported stuff, even though the system's calling that back later. In Android end previews, they had the launcher shortcut API, and so that was cool that they had, and they removed it, but it looks like it might be coming back. But what they did is, like, a messaging app could have shortcuts to directly message someone, and they don't want to reveal this to everyone, but because they only trust it for themselves, and that's understandable. But they do want the launcher to be able to access it, and so they can have a non-exported activity, and then this is all proxied through the system. System checks, is this the default launcher? It trusts it, and then it can launch these non-exported activities. So file providers, as I mentioned before, like, don't use SD card paths. You generally don't need to export file providers. If you're using one in a widget, you really need to, and there's no good way of doing that. But generally, you don't need to export these. So then it's secure. You can keep your files private. No one randomly can access it. But it can be accessed if you're starting another activity and giving it access, or sending it a result, or some other method of interprocess communication to transfer this URI over. It also means that other apps don't need SD card permission, which this is getting to be more and more of an issue, is that users aren't going to want to, they don't want to accept, granting a permission on another app, and other apps might not even declare it. So like, if you're sharing a photo with a photo manipulation app, then maybe this photo manipulation app, it's a modern app, it doesn't even, expect to use the SD card until it's writing to it. So it doesn't have the permission, it tries to read, and it doesn't know to check your URI and guess that it's on the SD card and prompt the user preventatively, so it's just going to crash, and users will blame your app. And again, you can check the binder calling identity. So you could even return a different URI for different processes if you had some reason to. And it can also be smart. So I had a widget developer talking to me. So he does like this weather map widget, and he wanted to. He has to generate a bitmap for it. It's a very expensive process. He's querying a server. So he was getting a portrait and a landscape bitmap for each size widget always, and this was expensive. And how many people actually use their phone and landscape at the launcher? Very few people. But the ones that do are the ones that are going to email and say, hey, this looks bad in landscape. So he's saying, is there a way that Nova could tell me what mode it's in? If it's just optimized for Nova, that works. But actually using a content provider, he doesn't need to do it just for Nova. He can see this information. So what he ended up doing is he has a content provider, and he has 2 image views in his widget. He has 2 views in his widget, and they both, image view, portrait, image view, landscape. And in portrait, he has both of those views, but one is just a regular view or a frame layout or something, and the other is the actual image view. And then he sets a content URI for them. And then he can tell which view is asking for it, so that he knows what dimensions to use. So content provider is pretty smart, and this is really cool compared to just a normal file. But there's transaction too large exception. So how many of you have hit the transaction too large exception? Yeah. It sucks. This is often it is your fault, but it's not always. And so it's very tempting if it's not always your fault, you get it and you just think that's not my fault, I'm not going to worry about it. So do worry about it. It probably is your fault, but it's not necessarily. There's a 1 meg limit for all the transactions on the system. So if you're trying to transfer, 5 bytes, and I'm getting some widget is sending me a bitmap through the binder transport, and it's 1 meg, you get a transaction too large exception, even though you're sending 5 bytes, you definitely didn't deserve it. So this is unavoidable, and it sucks. Your app might crash, the other app might crash, or worse, things can suddenly break and you don't know it. So this happens with widgets. I had Take Calendar widget. He draws these little lines of 1 color. So it's a blue line. It's 1 pixel high or something. So he was using set bitmap for that. What's the harm? I think he just stretches the bitmap. So it's 1 pixel by 1 pixel. There's no way this is causing any issue. But he's getting this weird behavior where every once in a while for some users the widget no longer updates, and it was an issue. He was using set bitmap. It's, even though it should just be this tiny bitmap, maybe on some devices there was some issue it wasn't, or maybe he's just hitting the generic transaction too large exception because someone else was transferring a lot. But he hit this issue, and the launcher wouldn't crash, his app wouldn't crash, but the system would catch this exception and silently ignore it and block his widget from doing any further updates. So this is really bad. And ultimately, you can't always avoid it, but don't use set bitmap to try to avoid it. So don't send and receive large amounts of data. Don't use set bitmap. Never set bitmap. Remote views have set bitmap. It's very tempting to use because the other is set image view URI, and that's you never use image view set URI directly. But that's set image view URI. It's a way of setting an image that's, you can use a file provider, you can use an SD card path if you're not supporting Android N yet. And it's the launcher, generally the launcher still loads this on the UI thread. Nova tries to load on the background thread if it can. So it's still not great performance, but neither set bitmap. And this, you're just sending a short string, the URI. So the actual IPC over binders is minimal. And then the launcher can go and read the file like it opens a normal file. And that's safe. When you're designing these APIs, remember to use small or paginate the results. Generally, if you're going to have a large data set, use a content provider. But if you're going to return between 5 and 100 items, maybe using an array or a list in a binder transaction makes sense. Just be cautious. Package manager is the big one. So this package manager should be a content provider, but it's not. So if you want to get a list of all the apps on the device, like your launcher, and you want to display this, the user might have 500 apps, they might have 1,000, they might have 4. You don't know, and when you query, you might get a transaction too large exception. This is especially true like if you're trying to get metadata for all the apps on the device. That metadata can sometimes be very large amounts. So when you're using package manager, just be very defensive that like, if you're just querying email apps, okay, that's great. If you're querying, email apps and SMS apps, don't just query all and then filter it yourself. Just do 2 queries. Likewise, if you want to query all apps like a launcher needs to do, sometimes you just need to do try catch. And so this is ugly, but it's kind of a necessity. If you catch a transaction too large exception, sleep and try again. You can do this in a loop to try 5 times. You could just do it once. Ultimately, at some point, you don't want to just do it infinitely because then you're just using a lot of resources and it might just be crashing infinitely. You can also try catch maybe once you sleep and try again, and then you can try a different approach. So like in the case of getting all the apps on the device, normally you use query intent activities. But if that's failing, then instead you can get a list of just the packages installed, get installed packages. Once you have the packages, you can query query the package manager for each app individually to find out what activities it has. That's much slower, it's using more resources, but it's using smaller individual transactions. So we talked about write strong binder before. This is a strong reference to your binder. So when you send this binder over to another app, as long as it holds onto the reference, it's going to hold onto your binder. And this is dangerous. So don't trust a third-party app to do it right. If you're using another person's API, when you send them a binder, make sure it's a static binder, not a inner class. And if you need to access your own activity or something, use a weak reference to do it. But also don't trust yourself to do it right. That like you don't always control what version of the 2 apps the user has installed. And even if you think you do, like things can slip through. So there was a time when like Tesla and Red was holding on to Nova Launcher with a strong reference, and so I was leaking because of that. And then I fixed it in both places. I fixed Nova so that that can't happen again, even if I mess up Tesla and Red. But likewise, Tesla and Red I fixed so that it's not going to do that. So just be defensive. Remote views. So remote views are weird. You've probably used them either in notifications or in app widgets. A common misconception is a remote view is a view, and it's not. It's a set of commands. So remote views are commands. You write the commands, you send them over to the system. The system sends them to the launcher, then the system UI for the notification, and that inflates it, and then it kind of executes these commands on it. So like for something like set text view, this is really, you can see, so set text view is a wrapper for set char sequence. Set char sequence is adding this action. And these are all reflection actions too. So I mean, not all, most of them are reflections. So that's also a performance problem. Then likewise for like scrolling widgets, normally if you're making a list view, you want to use a view holder, you want it to be fast, and you don't have control over this anymore. That like the launcher can't make a view holder because it doesn't know how you behave, what you expect. Maybe you can't reuse views. And you can't tell us how to do it because remote views doesn't have an API for that. So remote views are weird. They also haven't been updated in a long time. So like app widgets it's an old API. Like Honeycomb, it got some new life, and then it's kind of been static since then, which is a shame. So why use multiprocess in the same app? Generally don't. It's a pain. It's not a good practice. Users also get confused if they see 2 processes. Like they want to know what you're doing, why you're using more memory in 2 processes rather than just 1. But you can actually use it to avoid out-of-memory errors. So if you have something like a launcher, this is running all the time, and then sometimes you're going to launch into something where you're going to crop a bitmap, or you're going to load data from a theme or an icon pack or something, or show wallpapers. These can be very memory intensive, and so if you have 2 processes, each has their own cap on the memory, and then also maybe your secondary process can go away. Also, Android has a non-compacting heap. So what this means is that you start off, you're just using 1 meg of memory, and that's great. Then you're going to show a bitmap. You grow. You need 5 megs for this, so now you're using 6 megs total. Then you're done with the bitmap. You free it, but you're still using 6 megs of memory. It's just you have 5 empty megs available to you, but not to other processes. So once you blow, you're stuck at that value. And so if your app is relatively short-lived, it might not be too big of a deal. But if it's long-running, or like if you have a slow startup time, your user's going to notice when you get kicked out of memory. So using multiple processes can help you avoid this. You're not going to grow the heap in your main process, just in your secondary one, which maybe you don't care about as much. Also, as I mentioned, Leak Canary does it for debugging. Firebase now also does this, is that if you're using Firebase crash reporting, it has a second process where it like gathers the crashes, queues them up, and sends them over to Firebase's app. And then Firebase's app actually sends them up to Google, or Google Play Services as part of Firebase. Why use it at all? You don't have a choice. Like, most of the things you're doing interact with the system in some way. So like when you're drawing to the window on the screen, there's a window token, that's a binder, and it's going to the system. If you're interacting with any other app in some way, just a share intent, that's IPC. And permissions. I guess I kind of already covered that, but you can get around permissions. In a sane manner, you can get around permissions, or you can protect yourself. Okay, so no one did interrupt with questions, but now, any questions?
How did you figure out there was a memory leak between you and the other Nova Launcher and the other app that you were talking about?
Well, so that's Tesla in Red, so that's my own app, which helps. But
can you actually repeat the question?
Oh, sure. So he asked, how did I find out that there was a memory leak between Nova Launcher and Tesla in Red? And so these are both, I write both these apps, so that helps. But it's, partially it comes from users reporting, and it's hard to trust users. Users always, complain and praise performance, and you don't necessarily know what's true and what they're imagining. But it also just comes from, you can use, like, in Android Studio, you can see the memory usage, so you can see it growing over time. The easiest way to detect a activity leak is to rotate your phone back and forth. When you rotate your phone, generally it's creating a new activity, and so it's going to kind of spike a bit, and your memory usage is going to spike a bit, and then it should fall down as it does all the garbage collection. If every time you rotate it's growing a little bit, or even just when you first do portrait to landscape and landscape to portrait, if it's notably higher, 10% or 20% higher than what it was before you did the rotation, then that's probably a memory leak. And you can hit the garbage collection button in Android Studio a couple times to make sure. And then once you suspect there's a memory leak, you do a heap dump. Again, there's a button in Android Studio. You can analyze this using there's Eclipse map memory analyzer tool. And then it's a pain. Generally, you look at the dominator tree. And so then it kind of shows this activity has it has all this memory because of these methods, these fields it holds. And then sometimes you'll see, or you can even search. You can search for your activity, and you see, my activity is listed here twice, and I should only have one instance of it. But Leak Canary is really good for helping automatically find leaks. I highly recommend it.
Do you have any suggestion for how two apps can share credentials, or even authenticating one app to the other?
So he was asking how to how to share
user credentials.
Share user credentials, or how to authenticate one app from another. So you mean like in two different apps, not two different processes in the same app?
Yes, two different apps, but from the same company.
So you could use the system account manager, which has its own, users sometimes don't like seeing an account listed there, but that's kind of the official way of doing it. First, you need if you're not using that, you'd have to kind of decide, do you want to have one app as the master, or either app works? So I'll assume that you want either app to work. So like, let's say you have you have a website that the user logs into, and maybe you also have a forum on that website that can use the same login. So user installs either app first, then they log in, then you want to share that. Each one could have a content provider that kind of shares their settings, and including the auth token or whatever. When you don't put a permission on a content provider, because third-party permissions don't work. But when someone connects to that content provider, you can verify the identity of it. So you use binder get calling UID. Then you can use package manager to find all the packages installed with that UID. 99% of the time, a UID only has one package associated with it, but that's another method you can use. I don't recommend it though. You can have different apps share a UID and then share state that way. But don't do that, it's messy. So you query the UID, and then you find the package. Then once you know the package, you might, depending on how secure it needs to be. If it's a bank, you really got to trust it, so you want to verify the signature is the same. If it's a more casual thing, then maybe it's fine if the signature isn't. The reason it could be an issue if the signature isn't is that like someone might take your secondary APK and hack it. Maybe they're hacking it just to change the color. You use green, they wanted pink, but maybe they're hacking it to actually intercept the data or steal the data. So you can verify the signature that's signed to the APK. If it's valid, then you can go ahead and do that. At least send the info over. So I do something like that for, I have another app, Widget Locker, which it's kind of an older app, but it let you customize the lock screen. And so I have some settings in Nova, like when you're configuring the unread counts, and basically you would always want to change them in Nova Launcher and in Widget Locker at the same time. And so then I guess actually no, just Widget Locker has a content provider for its settings, and so it trusts any app from me with my signature, and then I can go in and I can just overwrite Widget Locker's shared preferences from Nova Launcher so that they match the settings there. Yes?
You said shared user ID was messy. Why is that?
You can't switch to using shared, so he asked shared user ID, why is shared user ID messy? You can't switch to using shared UID if you started without it. And Android, like when they originally designed Android, they had a different plan for how it was going to work, and I don't know exactly how it was. But they mostly abandoned whatever that was, and it's kind of just left there. So like sometimes when you uninstall, it doesn't clean up after, and it depends on the version, but it might not clean up properly after itself. You might get some issues, like if you install one app and then install the other, then you might have some subtle behavior difference than if you install them in the opposite order, especially if they're uninstalling and reinstalling. So it's just it's weird. And then if you're using that to also share processes, at that point, like why not just make it one app? So it depends on what your use case is, but I'd avoid it unless you had a very, very unique case.
Okay. So just use binaries or something.
Yeah.
Can you talk about the life cycle of the Android process and when the Android system might kill your process?
Sure. So that's, I mean, so he has to talk about the Android life cycle and when Android might kill your process. So that's something that don't count on it killing at any predictable time, that like it could happen anytime. Android, the idea is that you shouldn't worry about when it could happen. You should only worry that you preserve your data. And so then the user doesn't even need to know that like they're using your app, they switch to another app, they come back, and you restored state perfectly. It just took you a little bit longer, so they don't notice. In practice, of course, we do notice because it's going to take us a while to load, or sometimes we don't save state properly. Android it has a list of priorities, and so it prioritizes the launcher, whatever the default launcher is. It prioritizes apps that currently have a foreground service or are bound to having a foreground service. That's a service that has a notification icon in the corner. And it prioritizes the foreground activity and activities that are bound to the foreground activity, or services that are bound to the foreground activity. And occasionally it prioritizes you have an activity on top of another activity, and it might prioritize the one behind it if this activity is transparent. And sometimes you have transparent activities that are opaque, but the system thinks they're transparent, so it prioritizes that. And now with multi-window, it prioritizes both of those. So it uses these priorities, and then it looks at how much memory you're using and when you were last used. So if you're using a lot of memory and you weren't used recently, it'll want to kill your process. If you're just using a lot of memory but you were used recently but memory is low, it'll want to kill your process. So the best way of avoiding getting killed is to not use much memory. Does that help? Anyone else? Come on, Franco, you got something.
No, there's another way to do that. You can have roots. You can change some things, and you can change the priority of the kernel. And every time the service is called, like at the start of the command, you can just do an echo and send it like an unkillable value, and boom, it's roots forever. But don't do that.
So another method for kind of hanging on. So in Android 2 point something that actually worked, you could use, I don't remember what the command was. There was actually an API to make your process stick around. Am I out of time? Well, we can talk later. Thank you.